For architects, land developers, and 3D printing enthusiasts, modeling real-world terrain is a surprisingly frustrating process. Traditional tools force you to download generic, rectangular blocks of the Earth. These massive square tiles waste printing filament, include irrelevant nearby roads or buildings, and completely fail to isolate the actual plot of land you're designing for. That is why I built TopoTwin. TopoTwin is an agentic geospatial mesh engine that fully automates this data pipeline. By simply entering an address, the system queries municipal tax maps to pull the exact parcel lines. Then it grabs high-resolution, 2-foot bare earth LiDAR data to construct the terrain. The result? A mathematically watertight 3D solid manifold, shaped precisely to the legal property boundary. Let's look at the live application. Over in the sidebar, you can search any address in Connecticut. The system features real-time autocomplete, querying ArcGIS geocoding servers with every single keystroke. Once you select an address, it instantly resolves and locks the exact coordinates. When we click Generate 3D Terrain, the background pipeline kicks off. You can track every stage in the live status monitor, from geocoding and parsing the parcel lines, to pulling elevation samples and running triangulation checks. And look at that. The resulting 3D model is clipped perfectly to the property line. Above the visualizer, we can toggle between different rendering styles: solid, wireframe, a combined view, or solid plus contours, which dynamically slices the mesh at fixed elevation intervals. If you're working on a site outside Connecticut, you can simply upload a custom GeoJSON, KML, or zipped shapefile boundary right here in the sidebar. This overrides the address search and immediately projects your boundary to Web Merciator, queries the USGS elevation database, and builds the mesh. From there, the model can be exported instantly to an STL for 3D printing, a wavefront OBJ, a 3MF file, or a vertex color PLY for direct rendering in Blender. Let's look under the hood. TopoTwin brings the core concept of the Kaggle course to life. Agent equals model plus harness. Let's look at how the harness operates. First, structural and semantic gating. The agent runs behind a strict policy engine. Viewer roles are completely blocked from executing raw shell tools. On top of that, a semantic gate intercepts all coordinates before external API requests are made, instantly blocking and logging any queries, targeting restricted locations like the infamous Area 51. Second, the validation-driven self-repair loop. Organic property boundaries often create messy, non-manifold edges. TopoTwin automatically pipes every generated mesh through a try-mesh validator. If open boundaries are detected, the self-repair loop steps in. It corrects face normals, patches holes, and dynamically thickens up the base up to 3 times until the validation harness returns a clean pass. Third is observability. Every single geocode, parcel coordinate, and repair loop iteration is serialized directly to the file vibetrajectory.jsonl. This gives you a complete open telemetry style log of exactly what the agent did. And here's the final result. This is a physical print of a terrain model generated by TopoTwin. Notice how clean the flat solid base is, and how the vertical perimeter walls follow the exact municipal boundary lines without any stringing or overhang defects. The bare earth LiDAR captures the subtle elevation changes of the site, which is incredibly valuable for presenting clean models to clients or town planners. To get a print this clean, the TopoTwin guide recommends using the arcane wall generator in your slicer to neatly fill those sharp property corners. And if you're running a high-speed 3D printer, dropping your outer wall speed and acceleration just a bit prevents mechanical ringing along those irregular perimeter skirts. With TopoTwin, we've transformed raw, non-deterministic spatial data into a physical watertight reality. The project is fully open source, thoroughly tested, and live right now on Renderer. Thank you for watching.